Hi, I'm Phil Kerner of the Tool and Die Guy, broadcasting once again from snowy, freezing cold Erie, Pennsylvania. You know, about 10 years ago, I started the Tool and Die Guy site just to share my knowledge because I went through such a great apprenticeship, and I don't know what the training is like now. And we have a lot of discussions about that at the Tool and Die Guy and on my other social media, the training. And always want to make sure that the things we all know, the older generation, is getting passed down. Well, one thing that came across my desk a few months ago was an invitation to speak to a group of students called the Williamson College of the Trades. And I had never heard of that particular school, and so I did some research on it. I was so impressed. And what this is, what you're going to see here, and I'm actually posting this by request. Somebody did remind me that I said I would post my time with these students and a video. So it's a Zoom call. This isn't a Hollywood production, all right? But it's a live Zoom class, me answering their questions that they throw at me. And these are hungry, eager to learn students. Again, I was so impressed. You know, every one of these kids wears a tie because at that particular institution, you wear a tie to class. And then when you go to your lab, you dress more appropriately for machine shop or whatever your lab is. So what follows now is my live interview by request via Zoom with the students at the Williamson College of the Trades.
Phil, how you doing?
I'm doing well. A little rushed. I left work a little early to get here to be with these guys today. I don't know if do we have any ladies with us today, or is it all just the guys?
It's all guys. We got one back there. There's a laptop up there. We just had a couple guys come in, so we have everybody's kind of joining us now. You should be able to just grab one of those and log in.
I like your setup.
Well, you know, because of the work I do online, I apologize for the big microphone and the headset, but rather than change everything, this just works for me. So that's why I just leave it alone. You know, took me a while to figure out I've got a soundboard here hooked into the computer through an audio input jack and a mixer right here. So
You look like a YouTuber.
it took a while to get that all to work right. So I'm very reluctant to change now.
So, no, it looks like a pretty good setup there.
It's a good setup.
You know, again, we don't have it for a very long time. What I did was I printed out some of the questions that
I've got them right here in front of me.
And I passed them on to the students. Is there an extra one?
Yes, I got one right here.
So what I can do, Joe, if you want, I'd be glad to go through these questions and give some answers to start, or would you want to just freewheel? I'm fine with whatever you want to do here.
Oh, let's see. Are you on yet, dude?
Not yet.
what I might do, if you don't mind, Joe, is I will get a lot of feedback on this. What I'd like to do is I'll ask you a question. I had a couple questions myself. I'll run it past you first.
All right.
It says you've run a machine shop related business over the years. What do you look for when you are hiring a new shop employee?
Well, back in those days when when I had my tool and die shop from 1991 till 2004, it was interesting because I think this is related to a question about the trade too. You know, I used to get a call for apprenticeships for probably once a week. Somebody call, are you offering apprenticeships, right? And boy, by 2003, I was lucky if I was getting 2 calls a year. All right, that's how things had crashed by that point. When I was looking for, usually because of the way I was trained, I really liked it when up in Pennsylvania here, we had a 4-year apprenticeship program. And back then we called it having your papers or having your card. And that was always an advantage if I was hiring a new toolmaker, right? I really appreciated the fact that they had gone through an apprenticeship. As far as you'll find this psychologically interesting, some good advice I got one time. Back then, I used to try to hire kids from the county. I found that the farm boys, because of the work they had to do around the house and on the farm, seemed to be much more mechanically inclined. And you know, when you're out on a tractor in the back 40 and something bad happens and you don't have a cell phone in 1996, you had to figure it out or walk home, right? So I found that the kids from the county schools seemed to just fit the tool and die business better. Now, you have to understand too. We all grew up back in those days fixing our own cars and things like that, right? Now fixing a car is a big deal because of the electronics involved and everything. But back in the 70s, you know, as a kid, at 16 years old, I was buying 10-year-old cars, and you know, I could get a running inspected car back there then for $200, and basically, you did your own tune-ups, you changed your own tires, you did your own brake jobs, and there was a lot more mechanics involved for a young man just in everyday life back then. All right. So now I don't know how much of that is. You know, I know a lot of the schools, and rightly so, when they offer some manufacturing classes, it's going to be a lot of robotics and design and computer aided things like that. So I always like I always like somebody who's polite, obviously has a decent resume, takes the time to check the grammar, just the little things like that. I wasn't nuts about that, but professionalism was always the big deal to me, you know? And I was very impressed, as I asked Joe this morning, with you guys in the dress code there. You guys look great. What a bunch of pros. I mean, what you guys are being trained to do right now, just by the way you're carrying yourself, is a big deal in the professional world. And years ago, I apprenticed as a teenager, not my full apprenticeship as a toolmaker, but I had a mentor in a drafting room, and his name was Norman Reitman. And Norman Reitman was a registered professional engineer, and he never finished high school. He left early to go to World War II. And I know the test he took had 2 questions on it. They gave him 4 days. He had to design a bridge and figure out the steel and everything. But Mr. Reitman wore a tie every day. And it's funny thing about that tie, because he was the only guy in this plant that had 600 people wore a tie. Well, occasionally, because of the amount of employees they had, people would park on the street and the cops would show up and just want to talk to the owners and say, listen, tell your employees to quit parking on the street. Well, because Mr. Reitman was involved in management, he'd get dragged into the meeting. And the cops always insisted on talking to Mr. Reitman instead of the owner, because Mr. Reitman had a tie on. So you guys are in good company. I can tell you that. The instant respect. I like that. So I hope that answers your question a little bit. Earnestness and politeness to me mean a lot when I'm interviewing. I'm looking for somebody that's really wants the job and wants to do a good job and is interested in the interview process. That means a lot to me. That's just being earnest.
Well, can you hear me now?
Yep.
Okay. Yeah, again, I think the school does work very hard to get these students to that point. I mean, you know, a lot of them, certainly they come with those skills. They wouldn't be here if they weren't.
I agree with that. Right. I was looking at a lot of, I've been nosing around your website. So I kind of get a good feel for who you got there.
Yeah. And, you know, we do have a pretty good success rate of placing students in the jobs in their field. And so some of the other questions, like Jimmy, you had a couple questions about, give you a copy there. A couple of your questions are on there. About, yeah, if you could just, why don't you speak up?
Should I just talk live? Can you hear me from this?
I can hear you.
All right. So I have very, very minimal experience in a mold shop, plastic injection molding. So I was just kind of wondering, like, what types of molds have you worked with? Like medical molds or blow molds, or like with plastic or with metal, or what?
All right. So I actually started my apprenticeship as a tool maker at a place in Erie called Red Dog Industries, and we built die casting dies for Parker White Metal. And die casting dies are much like an injection mold. You've got a cavity and a core. The only difference is with die casting dies, the gating's a little different, the way they get the molten metal into a die casting die versus an injection mold. But the overall mechanics of an injection mold and a die casting die are pretty much identical. All right. You've got a core, a cavity. If you need side actions for the holes in the side, you slides and things like that. But over the years, most of my work was done in injection molds. I built a lot of injection molds. I built some compression molds. Of course, I built die cast dies. When I had my own shop for many years, the biggest customer I had for all those years was the Little Tykes Toys Company. So I built a lot of toy molds, all right? And those were fun to build. Working with toys was a blast. Back then, my kids were little. It was fun to go to Toys R Us or whatever and see some of my products on the wall for sale, right? So I worked with mainly I built some very high precision stuff, but a lot of toy molds and and primarily injection molds, B, die cast dies, and C, compression molds. I don't know if that answers your question or not.
Yeah. What kind of plastics would you work with?
That's an interesting question. As a tool maker or a mold maker, we didn't really work with the plastics that much. So what I mean by that, the engineers from the company that need this mold built, they decide on the plastic that's going to go into the mold. All right. And the only thing that affects me is two ways. I've got to apply a shrink rate to the mold. What does that polypropylene? I think it's 18 thousandths per inch. So you have to multiply every dimension on the drawing by 1.018, because a 2-inch or 5-inch long part is going to shrink as it cools. So 5 inches, times another 18 times 5, so you end up with 5 inches, whatever, 30 to 80 thousandths or something. And when it shrinks, it comes back down to size. So that would be the main thing that would affect me as far as the plastics went. I didn't choose the plastic, the customer did. And all I had to know was what plastic he was using. So the mold design would be correct. So the shrink rate would be proper. So as the mold, the part cooled after it came out of the press, it would shrink to the right dimension. Now, you have to watch out. There's a couple plastics out there that I think it might be PVC. One of them has formaldehyde in it, and it'll eat your mold up. It'll rot it out. So you need to make all your stuff out of stainless steel. I wish I could tell you off the top of my head, but there is a plastic that does have formaldehyde in it, and it'll etch your mold. So other than that, those are a few of the safeguards that I would know ahead of time if it had that type of plastic, that it needed to be a hardened material. But most of the time, you're governed by the customer who tells you what plastic to make the mold out of. So. Or tells you what plastic he's going to put in the mold, so you know how to make it. That's a little more clear.
Let's see. I have some other questions here.
Go ahead.
I have one. Are you concerned that U.S. manufacturing is being replaced with foreign manufacturing? I mean, I know it's happening, but do you think there's enough manufacturing in the U.S. that we don't need to worry about shipping stuff overseas? Or
well, that's a great question, because I was deeply affected by that, and because of the work I did in the toy industry, all that work within 3 years of China being let into the World Trade Organization, I think it was much more than the NAFTA agreement. Everybody used to get mad at NAFTA, but the Pacific Rim is where all the tool making work went. All right, and so we were devastated here in this part of the country. I'm in the same state as you guys are. I'm up in the corner, up by the lake, right? And this area here between Erie and Toledo and Detroit, and this was a big tool making capital. And just down the road from us, about 40 minutes, is Meadville, and that's known as Tool City. So there's tool makers everywhere. Now there are still some tool shops around. But they're a shadow of what they used to be. Instead of having 100 tool makers, they might have 14 now. All right. And now some of that can also be attributed to the automation. I hate to use the word automation because there's not a lot of automation in a tool room, but the days of us calculating things out manually and moving a handle on a Bridgeport by hand and counting the dial revolutions, I've done that, right? Well, now you stick it in the CNC and it's 500 inches a minute, and it's accurate, it's repeatable. So that's eliminated a lot of manual labor too. But I've always said this, what you guys are doing down there with this college, there's always room for people who know how to build things, who know how to work with their hands, and are sharp. All right. There's always room for those people. Unfortunately, in manufacturing now, a lot of people complain about manufacturing because they don't have any skills. They go in, and we can take an unskilled person and put them in front of a machine, give them a set of safety glasses, and basically show them how to load a part, bring a part back out, maybe check a few dimensions, and do that all day. Well, that's not a job where you want to end up, right? You might do that someday just to get your foot in the door, but you don't want to do that much more than 3 months. You slit your wrists. I mean, that's a long day doing repetitive work like that. But there is a concern. Of course, there's a concern. I can't believe we offshored so much of our manufacturing. I mean, what kind of a country offshores their own manufacturing base? But we did it. Now, in some cases, it's coming back. you know, because it's just a matter of time. I've watched this for years. Back in the 80s, all the work went to Hungary and Poland. And then their economy came up, and then it went over to Spain for a while. And then it left Spain. It just moves around. And now it's China. Well, China is going to get more affluent, and their wages are going to go up. Now, the only difference between them and the other countries is China is a communist country, right? So they can kind of oppress the workers a lot more than some of those other countries, kind of keep those labor rates really low. So, you know, there's the tool shops are still out there. I mean, I know we've got some really still good ones here in town. They're very progressive. The time of having a couple Bridgeports and a grinder and making a nice living in your garage or a small outbuilding, I don't know how you would do that anymore. And then, of course, to get into some CNC work and everything, that's gonna be some capital investment, right? But so, am I concerned? I'm always concerned about that. We took a big hit here, but there's always room for people who are talented. I've been doing this for over 40 years, and I have never been laid off once through 3 recessions and turndowns and the pandemic. I haven't missed a day, and that's not just because I'm that good. All right. The question is, and my biggest thing I could teach everybody is you just want to be an asset to the company you work for. You know, you want to really feel bad if you left. And that's a big part of my day is still, I like to impress my managers and my owner of that company that I get my work done quickly, efficiently, and I'm an asset to the company. And that, when you become an asset to the company, that's important. That's why they keep you around. So,
Dominic, you had a couple questions.
What's that?
Dominic has a couple questions. I'll let him.
One of my questions was, when you started out in the machining industry, what did you typically have the most trouble with starting out?
You know, I'm trying to think. You know, I started my apprenticeship, and I went to school, a trade school for design work, and I went to college for a year, and I didn't care for it, so I decided to get into an apprenticeship. So I hadn't had that 3 years of experience in a trade school, so I would know really a little bit more about how some of these machines operated. So everything was a little bit of a surprise to me for the first 6 months. You know, I was lucky. Again, back then, there was so much work to do and so much manual work. There was always something simple for an apprentice to do until you got better and they trusted you to give you nicer work, right? So I would start off on, maybe saw up some blocks and maybe square them up, and they weren't critical blocks. They might have been something to bolt to the outside of an injection mold to mount a cylinder on or something. So if it was a little off, nobody was going to freak out. It had nothing to do with the cavitation of the part. So, so between the drill press work and saw work and light mill work, 6-8 months of that, I got my feet wet, and then the lathe work, and then of course that kicks the night school in, right? So now I'm going to night school 2 or 3 nights a week, and I went more than I was supposed to. Because I plan on starting my own shop someday, so I took welding classes and all that. In fact, when I had my tool shop, I did about 90% of the welding there when we'd have a mistake, because of the injection mold, if you make a mistake, you usually have to weld it up. You can't scrap a part that you've got a couple hundred hours in on a cavity or core. So I learned how to weld, and as time went by, I always found a big secret was I'd listen to guys talk at lunchtime, and I'd find out who the best tool makers were, because you could tell who they respected, right? And they might complain about this guy, but they'd say, man, boy, is he good. Well, that's the guy I would latch on to. I would always find a way to worm my way in under toolmaker number 1 and toolmaker number 2, just to pick their brains and get their habits of how they do things. And that served me very well. Always hanging out with the smartest guys in the room. And believe me, back then, they weren't abusive, but boy, they were kind of arrogant. You didn't want to go up to them and explain that you did something wrong, but you didn't get screamed at, but it was tough. But they had so much pride in their work. They instilled that in you. So no, just getting my way around a shop as a kind of a new guy. The whole thing was a little bit of a challenge for me at first, but it was kind of my blood, as my family's been doing this for 100 years. So I think I might have some DNA things going on there. So
it's funny because just like you said, when I started, I was a draftsman. So when I started doing that, it's the same thing. You're sitting near the guy that's the best draftsman, and you figure out what is he doing.
Right.
Yeah, like Jake back there. He thinks he's the smartest draftsman. But you know, you sit next to that guy, and the guy, he just has such good habits, and you try to emulate that. You know, you try to do that. That's a good thing.
Yes, it is.
You forget about that. You know, at least I forgot about it. Let's see. We got some other questions here. When you talk about these molds that you would make as a tool and die, or you know, making these injection molds or whatever, so you're really the main thing you're working on is the part that will create 1,000 pieces or whatever, right? I mean, that's why you say you have to spend hundreds of hours working on that mold.
Right. So a customer comes up with an idea for a plastic part. You know, I've got a lot of them here because right now I'm teaching an injection mold class online, and I saved a box of parts from my own company, thankfully, and I saved a box of prints. So I can actually pull out a plastic part and find the drawings that match it. And if I'm lucky, I've got the quote there and the hours we spent on it. So you can see the whole start of the process, the whole process from beginning to end. So, you know, a company like Little Tikes, they're going to design a toy, and, you know, it might be a little toy car. It's going to need toy wheels. It's going to need toy seats. It's going to need probably a roof, a body. And they put that out for quote. And they would tell us how many cavities they want. You know, is it going to pump out 2 parts at a time, 4, and whatever. And then we'd quote that. If we were lucky, we got the bid. And then at that time, we were quoting about a 4 to 14-week lead time. Then the first thing we'd do is go to mold design. And the mold designer would put what's called the parting line on it. Where's the A and B plate going to split this part? And after the design was done, then that would go back to Little Tikes Engineering for approval. Okay. And off we went on making chips. So at that point, now we had several choices. Up until prior to 1995 or 6, everything that was 3-dimensional was built with tracing machines. Little Tikes would furnish a model of the cavity in the core, and we had machines that would follow that and trace it into the steel. Okay. After that, after 1996, 97, Little Tikes bought Pro E, and they started designing their stuff in that modeling space electronically. Well, that changed the whole industry. All of a sudden, we were expected no more models to trace from. You guys better figure out how to put tool paths on your CNC machines. Well, that was a big deal in 1996, 25 years ago. I remember I bought a computer to do that, and it was a Gateway 2000. I bought it used from some guy, and it had 40 megs of RAM, 40, and that was considered huge. And it was back then, it was $100 a meg. I paid $4,000 for a used computer. All right, with 40 megs of RAM to do these tool paths. Then I had to train somebody to do it. And when we first started out, nobody knew how to do this. So I had a guy in town that had done this for years because he was at a very advanced company. He would take the models, write the programs, and back then he put on a modem and send them to me overnight. Then I would download into the machine. So eventually we had to buy our own CAM software and program our own 3D work. But that was the beginning of the end of the old tool maker doing the tracing work and the fitting work, because the CNCs, you know, once that thing's roughed out, a finished pass might take, 5 hours because you're just stepping over a couple thousandths at a time and tracing a cavity out. Let that run all night. You come in the morning, there's a finished cavity. It's pretty cool, actually. But the amount of money we spent in a short period of time was rather shocking, to say the least.
Hey, any other questions? What's that?
I was just wondering if.
Go ahead. Well, I don't have a mold print. Do you? I don't know whether. I guess would there be a way for you to show us a mold print?
Well, uh, it's interesting you should ask that. I was just working on some. It's a long story there because I saved all these drawings. They're huge. They're really big.
I saw on your website you have maybe we could just buy something, because I'll be honest, it's hard to find drawings for these guys to work on. I know maybe they're kind of complicated, but do you have things that we could, like a set that we could buy?
Well, okay, so here's the deal. I opened a set of drawings up a couple weeks ago that I've had for a year, and they're actually upstairs right now. The drawings themselves, I think that would be an E or D size. They're 34 by 44, so they're big. These are old blueprints, all right? So back in those days, you did all your drafting work, as you guys probably know, in the drafting tables on the tracing vellum. It almost was like almost tracing paper, right? Very thin, but and then you would run that through what was called a blueprint machine, and this ultraviolet light would transfer the drawing to this heavy paper. And blueprints, the ones in our industry, they were kind of inverted to what you'd think. They weren't blue with white lines. They were white with blue lines. Okay. But it's very heavy paper. Well, I collected those for years, and I've got several sets of these old blueprints down here, and they're cool, but they're really big. And when I scan them in, they come out all right, but because of the aging of the blueprints, I've got a lot of yellow marks from the ammonia. They're okay. They're kind of be better for the man cave, kind of a vintage print, right? Well, I'm looking around here the other night. It's so funny you asked this. Right below this drafting table I'm sitting at, I've got a couple bins of drawings from my shop. Now, by the 1990s, we weren't using blueprints anymore. They would just plot them off on white paper, and off we went. So again, I've got these big drawings down here, and it just dawned on me last night. The last part of my career, and when I had my shop, I didn't have a designer in house. Excuse me. And I shipped all of that out to a local guy who did all my design work. Well, I called him today and I said, Dave, do you still have any of my stuff? And he says, let me look. He called me back. He says, I have 10 CDs worth of your mold designs. You can have them. So I've got all these mold designs that I can bring into to AutoCAD, resize them. I did some today at work, actually. He emailed me a few. And the biggest problem I was having is a lot of the text is coming through yellow. I'm using AutoCAD Light 2004, so I had to figure out how to turn the text back to black, but it's pretty encouraging. So I've got enough here to keep me going probably till I go to the big tool room in the sky. All right. So I'll keep Joe posted on that one. What I'd like to do is teach a class based on a set of prints and how we did it, what the part was for. That's the way it should work. You should see a part, the design, the manufacturer, and then so you should always have a finished part. Now, I think there was a question on here. Did somebody write on here about the 3D printing affect the molding business? As far as I know, no. What it's really helped is the engineering part. Back in the day, you had a couple choices if you had an idea for a part. We had these things called SLAs, stereolithography. I don't know what the A stood for. Joe, do you recall that? The SLA model?
I remember hearing it, but I never really got too involved.
It was kind of like 3D printing, and these parts would come out, and it would give you a concept. They were brittle, and you couldn't do really big parts, but you could say, well, I like this, or let's change that a little bit. So you didn't spend all the money building an injection mold to find out, oh, this I don't like this way this looks. So that was a big advanced thing back then. So in my opinion, the 3D printing is just a great way to get the concept for your part. As far as I know, I don't know how anybody could ever 3D print as fast as an injection mold opens up and closes every 20 seconds and spits two parts out. But I believe, depending on the model of 3D printer you have, a small part can take 3 or 4 hours, right? So it's really good for the prototypers, I believe, but I don't see it replacing injection molding anytime soon, if that answers that question.
Ryan, where's Ryan? I got a couple questions.
Yeah. Over the years, what was your favorite project?
Well, mold making was always fun. And I can tell you, the benefit of hindsight, there were some days, I can tell you, building injection molds back then, it was tough. And the hardest part about building injection molds was the EDM process, the electrical discharge machining. Now, that was the most fun I ever had in a tool room, was running an EDM machine, because you had to calculate your electrodes up, grind them up, put flush lines in them, learn how to run the EDM machine. But boy, when you're trying to burn a gusset rib in there 2 inches deep, and that thing's just bouncing back and forth, and it gets an arc mark or something. So I always say 10 hours, because that was our standard day back then, 10 hours a day, went like that in a tool room, just like that, because of the work you were doing, always thinking. The work was rewarding. It was fun. It was a long-term project. You know, you had 14 weeks to produce a mold that would produce a good part. So I will tell you, I look back at all the things I ever built, but probably I've got it right here on my desk. This is a toy lawn chair. Okay. That was probably the hardest mold, probably one of the hardest molds Little Tykes ever made. I'd love to find the design for this one, but I don't know where it is. But this one, this mold, I believe, was actually run like that. That's the way the parting line was. This was the core. I believe we had a big cylinder coming in to pull to clear the legs, and then this whole parting line had to be fit by hand. We traced it out as close as we could, but that's all parting line. Every place you see open spaces in here, that's steel to steel. That all had to match, and it's a toy, so no sharp edges. So that was probably the most complicated, believe it or not, a toy lawn chair. But that was a big deal. That one was quite a piece of work by the time we got done with it. It's very impressive mold for that. So.
Let's see. You know, well, Brian and Aaron, you guys were doing something today. What were you guys? Somebody said you were doing something with EDM today.
Yeah, we just got a wire EDM and a sinker EDM for the shop.
Oh, cool. All right.
They're real small Sodics, so we're messing around with those, trying to get them up and running.
Technicians coming tomorrow.
Yeah, technicians coming tomorrow. They've been set up, but none of us know how to use them pretty much. So
okay, well, you know, it's interesting. One of my favorite EDMs that I used to have, again, I keep saying back in those days, but the one company that was the bomb was called the Charmel company. It looks like Charmills, and I think in Swiss they call it Charmy, but it just looks like Charmel. So they built really beautiful EDM machines, and those were big around Erie, Pennsylvania. But there's a couple other ones. Elox was around, but my favorite personal one was an Excello. And what you're going to find out there, you've got amperage and voltage. And I don't know what they look like now. Are these CNC EDMs or conventional? Do you know?
Yeah, they're CNC.
Okay. By the time the CNC EDMs came out, I never ran one. I paid for them for my guys. I was past that point. I'm sure that technology has improved a lot. I don't know if you're going to have to put flush lines in your electrodes. And we used to have to drill lines in the side of the electrode and tiny little drills into the surface to connect that. Then you would hook up a little hose, and it would look like 3 or 4 little 20 thousandths little, water lines coming down when you go into burn, because that cleared out the gunk. As you're burning away, you're eroding steel, and you're also eroding the graphite. All right. So usually, depending on the depth you're going, everything you do on an EDM, as far as I remember, was always 4 hits, 4 burns. You'd make 4 identical electrodes. The first one burns, but it wears out quite a bit. Second one doesn't wear out as much. Third one pretty much cleans it up, and the fourth one's nice and clean and gives you your finished depth and detail. Okay. So what you're looking for is you should be able to close your eyes, and that thing should sound like bacon on a frying pan. That's exactly what it should sound like. That's a good clean cut. If it's the servo's pushing too hard, you'll actually hear it rumbling because it can't get out of its own way. And if you run it too light, it might sound like frying grease, but not the bacon in it, and you're just going to wear out your electrode. It's just sparking away and really just wearing out the graphite. You're not making any good time. So I don't know. It'll be interesting if you're going to have to flush your electrodes or not. I did a video on flushing electrodes at the Tool and Die Guy. They make these little really cool machines called Westhoff drilling machines, and they run sideways on ball bearings, and you just sit there and drill your holes in the side of your electrode. But and I mean, I remember drilling holes in electrodes, 10 thousandths in diameter, 1 inch deep. So you gotta be really careful because they'll start walking out the side of the electrode. But 10 thousandths is a pretty small drill. I still have a couple in my box here. I'd hold one up, but you couldn't even see it. They're so tiny.
I think it's graphite though, right?
It's graphite. Yep. And then there's different grades of graphite. Hopefully you guys can find a tool shop around there. It's got every tool shop or mold shop or anybody with an EDM has a shelf full of graphite. It's cutoffs that they don't need, but they might need someday. Old electrodes they haven't used for 10 years. You can usually cut the part. We used to build them so they were square, so you could put them in a holder, and then the shape you were burning was underneath that. You could just cut that shape off, and you've got some nice squared up electrodes to maybe play with, right? So, like I said, any shop that does mold work always ends up with 5 shelves full of graphite they just didn't use or hoping to use for a rainy day, but they never do because you're always looking for 4 pieces of the same. So what you end up doing, you'll usually get a cheap bandsaw. It's hard to believe. I don't even know if Sears is still in business, right? You could go up to get a Craftsman bandsaw. You saw up your carbon, and then you square it up in a grinder, and then you put your shape on it, and then you put it in your holder. There's a whole thing to the whole process, but EDM is a lot of fun. But yeah, I'm curious if the CNC EDMs even need to have coolant or be flushed anymore. I don't know if that technology.
So the one we just got has a tank that fills up,
right,
to the wire,
right,
but it has the same oil coolant. But it only has 1 flush nozzle. I think you can get a few more to attach to it.
We used to just make our own manifold. So the 1 flush nozzle comes out. You get an aluminum block and drill 4 more pipe taps into it, and you can hook up. You can hook up ones, the plastic ones that you have in your CNC for coolant to just spray on it, or you can hook them up so you can put the pieces of vinyl tubing and connect it right to your electrode. So that's what you just end up doing is making a manifold to because you don't need that much. You're talking about once that tank's filled, the little amount you need to inject into the graphite electrode itself we're not talking garden hose quantity of coolant or dielectric fluid needed. Okay. But yeah, so there's a little bit of process going on there with EDM. I mean, making the electrodes and if you're going to grind them, you really should have a hood on your grinder with a suction system because that graphite ends up everywhere. So they make these things called vacuum guards. It's just a big hood that fits over your wheel and you hook a hose to it. And as you're grinding, it sucks the dust right in that and into whatever you're using for a vacuum. But, and what you learn to do is grind one way. So the dust keeps going up into that thing. It's amazing. Like I said, if you go into a shop that's been doing EDM for any amount of time and you were to walk into the front office and they have those drop ceiling tiles and you just poke one, you'll see the graphite come down off the ceiling. Yeah, it gets everywhere. There's a lot of shops that won't get an EDM just because of that. It makes a mess. It's not the EDM machine. It's making the graphite electrodes.
Aaron, I heard you were doing like Skills USA. Like what was that?
I did Skills USA this morning. It was just CNC program.
Describe, what is Skills USA? It's like we're competing with other schools.
Yeah, so I was a contestant CNC technician, so I had a program, CNC mill, a CNC lathe, 2 different parts. They weren't too super complicated. Like the lathe part was the same thing you had, which was just like it was
2
inch and a quarter diameter with 3/4 inch diameter that's threaded, and then a groove in it and a chamfer. Now I didn't have to make it. He had to make parts. It seems like precision machining, manual machining. I just had to make the program on the simulator, and then we just, because it's virtual this year, we just copied it over, and they gave it to, they emailed it to the Skills USA contestant. But then
I'm always trying to guess who's talking here because of the mask. Is that Aaron who's talking? Now, Aaron, with this competition? What year are you in your schooling here?
I'm a junior.
You're a junior.
It's second year. We skipped the sophomore.
Okay.
It's a 3-year program, so
okay.
Freshmen, juniors, and seniors.
Okay. So in the second year, so they've already got you doing some competition things virtually, though.
Yeah, I did it last year, but last year, with basically we went districts in person, and then COVID. I think it was late April is when we were going to have our state competition, and they got shut down. Basically, the process would be if you won a district, you go to states. If you win it, if you got first place districts, you go to national, or states, you go to national. And then for nationals, I think there is a world's competition, but it's very few and far between the competition numbers.
Yeah, it reminds me, first kid I hired back when I started my shop in 1991. I rented this little spot in this big building that was like an incubator. There's several different companies in there. And the spot that was available for me was in the back of the building, right along the railroad tracks. All right. So I quit my job as a tool maker and, got 2 kids, or back then I think I already had 3 kids. I'm 31 and it's time to start my own shop. So, get the money together, buy a few machines. I rent the spot. I put everything in there. Monday morning, I get there at 6 a.m. and I had a garage door. And it was a beautiful July morning. And I opened the garage door to let some air into the shop. And I look at the railroad tracks and I hear this noise in the bushes. Well, this back then we called them hobos. This guy comes wandering out of the bushes and he said, "Hey," he says, can I have a job?" And, I said, "Well, I'm really not hiring. It's like the first day I've had my shop." And he said, well, good luck, man. And off he went. Right. But when you think back to the apprentice I hired, the first guy I hired, he did compete and won some sort of a state championship in machining. And he went on to have a really good career. He started his own shop. He still has his own shop in his garage, about a half an hour from here. And he does real well. He's got some nice EDM equipment, some nice grinding equipment. He builds injection molds. And Scott, he was a really sharp kid, and he did what you did, Aaron. He competed and won something. I can't remember what he won, but it was a big deal back then, 1991. And he ended up having his own shop. He's got a nice little operation going out there. So you never know.
Yeah, I think the skills, you're on the machine side, but we have our brick shop. They're competing. I don't know. I guess carp shop. They do the same thing.
There's a list of competitions. It's a long list. There's
like speech.
Yeah, there's speech and debate.
Are the competitions mandatory, or you guys do that to challenge yourselves?
Just
yeah. Cool. Very cool. All right.
Yeah.
I'm just kind of looking through the questions too to see if we anything pop out to you guys yet that's left here.
I got one.
Yep.
Levi, go ahead. I'm sorry.
Okay, so I know you previously mentioned that your family has experience in tool and die. So what made you decide to get into tool and die business, despite it being in your background, stuff like that?
Good question. My family had this great history in the trade, and you can literally look it up. I finally joined Ancestry.com a couple years ago just to check it out. I was pretty certain this was true, but I just needed to see it. So I looked up my family's heritage, right? And my grandfather, Edward, was listed as a tool and die maker here in Erie, Pennsylvania in 1920 on the 1920 census. All right. So that's 100 years. So my grandfather had 3 sons and 3 daughters, and he taught the 3 sons some machining in the basement. And they ended up, the one son, Ronald, my uncle Ronald, started a company named R.M. Kerner Company. In fact, that's where I worked a little bit in high school. He ended up with 600 people there. R.M. Kerner is still in business. My uncle Ronnie passed away many years ago, but he built a very nice business. But my uncle Ed had the tool and die shop. And then my dad was the foreman. So I grew up going up to this tool and die shop a lot. Okay. And it was a beautiful shop. It was on the top of a hill. My uncle made a lot of money. He built his own golf course there. It was quite the deal. Going up to my Uncle Eddie's was like going to Disney World. All right. It was so much fun. But I still remember we'd go in that tool shop, and the smell of the EDM oil to this day. I can always tell when I go into a mold shop because I can smell that EDM oil. I don't think it smells like it used to. It used to be very, very noticeable. Well, anyways, to make a long story short, I'm 9 years old. My father passes away in May, and my Uncle Ed dies that owned the shop in December. So in 6 months, these two guys are gone. My aunt sold the shop 2 years later, and in 1974, the whole place burned to the ground. And that was the end of the Kerner Tool and Die Company. Well, it always bugged me that I missed out on all that. My brother was apprentice there, and he had a great career, and I missed out on all that. So for whatever reason, and something stuck in me that I wanted to recreate that someday. And that's what I did. I wanted to start my own shop. And, that's a whole different thing. Starting your own shop it's I don't care what area you do it in. It's a big expenditure of time. It's a big expenditure of money. It's a big expenditure of stress. Some people are just blessed in business. Some people have to work really hard at it. Being in business is a big, big deal, especially when you're going to buy equipment. So, I closed my doors. I didn't go out of business or anything, or declare bankrupt or anything. I just sold everything off and went back to work. Okay. Cleared the decks. And then in about 2010, I went into the inspection department with a part that I had machined an angle on, and they failed it. I said, well, how'd you check it? And I can't remember, the protractor or whatever. I said, why don't you use a sine bar? And they said, well, what's a sine bar? Well, I thought that's interesting. So I brought a set of gauge blocks home that night and a sine bar. And I told my wife, who knows nothing about tool making, I said, just film this. All right. I'm going to show me these guys how to use a sine bar. So it sat there for 2 months. It had 60 views, whatever. And I forgot about it. Like 3 months later, it had 11,000 views. I thought, wow, that's interesting, because I was getting angry that the time and I had put into learning a great trade was going to go to waste. Really? Am I going to spend all these years not perfecting, but really enjoying a great tool and die business and a trade and working with my hands, and nobody's going to get this stuff? So that's why I checked online. Back then I was doing a little website design, self-taught for my wife and stuff. And I looked online, and the toolandieguy.com was available. So I scooped that up, and that's how I got started. So the whole thing, back to the family and everything, in the end, all I ever wanted to do was to protect my family's legacy in the trade and my legacy in the trade. And as I've gotten more into it, people start sending me these vintage charts, and I restore them in Photoshop, and then I put them on my website. And I've got a little store going now. But it's always about trying to remind people. I think that one of the taglines on my website is, one of my things is to connect a past journeyman to the future journeyman. And that's why I end up with a lot of cool stuff here, and I really enjoy that part of it. I enjoy this a lot, talking to the young guys, and I enjoy restoring old documents and getting them on the web for people to look at. And the next step will be to convert all these drawings into a really good mold making class. So full circle.
Yeah. So is there still apprenticeship programs out there for tool and die, or you talked about it before, it sounded like it's kind of it's not quite as formal, or
it's not quite as formal. I guarantee you that where I'm at. When I first started at Red Dog Industries, like I said earlier, and this will be interesting to you guys. As I said earlier, I always try to find the smart guys, right? Who does everybody respect? Well, everybody I respected in that shop had come from a place called Anson Tools and Gauges. So I quit and went to Anson Tools and Gauges. I was the first person to ever leave Red Dog and go to Anson's. It was usually the opposite, right? So I went to Anson's and took my apprenticeship there. They wouldn't even, first step was I had to take a test just to apply. They wanted to make sure I even had any mechanical aptitude. Once they got the test results back, then they scheduled me for an interview. Once I went to the interview, there were 7 people in that room. I had a tie on. I was sweating like just sweating. I was so nervous. I still remember that day like it was yesterday. The owner was there. His personal secretary was there. 2 foremen, shop, the vice president, the engineer, and the apprentice supervisor, and me. and they grilled me, for about an hour. That's how serious they took the apprenticeship program there. That's how serious. Now, down here in the studio, I've got a big book. I kept all my papers for my apprenticeship, and over the last several months, I condensed it into a small book, and that's up on my website. It's called the Apprenticeship Standards. It tells you all the questions they asked me, what tools I was supposed to own, the application I had to put in. That's how seriously they took it. Now, fast forward 2020, about 4 years ago, we were going to start an apprenticeship where I work, and they said, "Would you help run it?" Okay. I said, only on one condition: I get a say in who we hire. Of course, they didn't do that. They hired from within. Good kid, but I didn't even think he was that interested in the trade. But he ended up working out all right. But the problem was, it's just not as formal as it used to be. It's kind of aptitude based. So if you can test out of some things, you can skip it, and that's okay. And then the night school started falling apart. Then COVID hit. And then the night school doesn't have enough teachers. And the night school only insists, because it's a city school, they only want union teachers. So it turned into a little bit of a mess. And fast forward, this guy's 5 years into it, and he still doesn't have his certificate or papers or whatever he's going to get. When I took mine, it was 4 years, 8,000 hours. I've got it hanging on my wall in my den, my gold seal from the Pennsylvania Department of Labor, that I'm a certified journeyman tool and die maker. It's like 4-year, college, right? Except I got paid for it. So, to answer your question, I don't think it's as formal as it used to be. I don't think it is. I think there's a lot of chefs in the kitchen there. It used to be between the company and the state labor board, how you ran your apprenticeship. In fact, I've got a plaque right here that I'm certified to teach apprentices at my last job by the state of Pennsylvania. And because I had to show I had some standards, right? And I think the one thing they really liked is I had my papers from the state of Pennsylvania Department of Labor. So there was that hierarchy that back then. I don't know if we've lost that or not. I don't know. I wish there's a lot of chefs in the kitchen, community colleges, night schools, trade schools, online schools. I don't know how they're all kind of working it together to make sure this kid comes out of this program certified to do something. And what certification is it? Is it a plaque, a paper, or are you guys familiar with the term NIMS?
Yeah.
That seems to be the thing. So I'm a little backwards on that, and I apologize for that.
I had to do that in high school when I was a coach. That was our state standard to pass.
Okay.
There was 11 tests, I think. It was like milling, grinding, like 2 lathe operations, CNC. You had to do at least 5 of the 11 to pass high school.
Well, what you guys are doing there, I mean, what I've seen online and meeting you guys today, I mean, I can't begin to tell you how impressed I am by this place I never heard of before. Okay. I really can't believe this. I love the fact you're getting in-class instruction, and then you're getting your hands-on instruction. That's the best. That's the best. The way it used to work, you didn't get to be a designer until you were a really good toolmaker or a machinist, because then you understood it, right? You guys are going to have such a leg up on the industry because you already understand how machines work, right? Now, somebody, to finish this up, because what do we have till 4:20? Only a minute left here.
Yeah.
Somebody said made a number of parts. You made a number of parts in a variety of ways. Let's see. No. Have you ever found a drawing that creates too many challenges to make the part efficiently? Let me finish on that one. Okay, this will be my get off my lawn moment. All right. The best drawings I get to work from these days are usually ones that they have a digital file, like I can get a DXF and bring it up in AutoCAD and double check a few things, but that doesn't tell me my tolerances. But the problem we ran into in the machining world is the geometrical tolerancing. All right. I can figure it out, but I had to take a class in it. All right. And I still keep a little chart on my bench for the symbols, because half the stuff I get drawings on a daily basis from 1938, from 1992, and then all of a sudden the newer ones have the GD&T. And I told the instructor, I said, I don't have a problem learning this, but I hope you're certainly teaching this to the designers, because you get it. So my problem is I think the designers don't get it. So they're putting all these true positions and datum things on these parts that I don't know are necessary, but some of these true positions on a milled part are just ridiculous, you know, and you know, when you've got a 17, 30 seconds hole in the middle of it, you know they're going to put a half 13 bolt through that. Why does that need to be true position to the edge of the plate within 2,000ths? You tell me.
Well, that you know, honestly, that was one of my questions, because I was a designer, and I could tell you that I would have the machinists would come in and they'd throw this stuff on my desk. Why did you do this? They just get at me, you know. So you know, you learn that you don't need every dimension doesn't need to be to, you know, to a thousandth of an inch.
As I was restoring some of these drawings from my mentor, he was so good, that Norman Reitman guy I mentioned at the beginning. I actually was running blueprints one day, and I ran 2 copies for myself, 1978, and I've got 2 drawings from him here, and I turned one into a poster that's on my site, and he was so good. I saved that drawing from him just because of his excellence. He was not only brilliant, but he was just so good at design. But or drafting, his skill as a draftsman too is impeccable. But again, he understood mechanics well enough that a lot of his dimensions, as I'm looking, he put fractions on them. Who puts fractions on a machine part anymore? But you can. You know, you can change in AutoCAD, you can change the fractional dimensions. Does that plate really need to be 10.500 by 8.250? What's it doing? Can it be an 8 1/4 by 10.5 inch plate? You know, it's holding a cylinder on. It doesn't need 3 place dimensions on it in a datum line, right? But I understand when you're using software. I use AutoCAD every day. I use it more as a shop tool for math, but I use it every day. And you know, you can change your tolerancing. It's easy to do, but I think what we're seeing here is a lot of kids coming out of engineering school that are really good manipulating data, right? They can draw 3D wireframes and make beautiful curves. But when it comes down to dimensioning it so it can be machined efficiently, I think that's where we're losing it in a big way. That's my biggest thing, is over tolerancing of parts. I don't mind tight tolerances. I have no problem with doing them, but it is aggravating when you have a pretty good idea that I'm spending a lot of time doing this, that I don't think it needed to be that tight, but that's just me. So.
Well, because these guys are running behind, they have a pretty tight schedule.
Not a problem.
So and I'll, you know, Phil, thank you so much for joining us.
Absolutely.
Thank you. Anybody? Thank you.
Thank you. Thank you very much.
So, you know, that gives me a lot of hope. Very impressed. I'm very impressed by what this institution is doing. I can't wait to get down there someday. So that's it from here. You know, I'm all about the training and passing down the legacy. For more information about what I do, toolndiegui.com. If you're looking for some apprenticeship stuff, it's all over there. So I'd just like to thank you for joining me on this video tonight.